Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another video on our system designing playlist. And the problem or the application that we will be designing today is a very important and a popular problem for any system designing interview, and that is distributed job scheduler. So just to give you an idea, a distributed job scheduler is an application where the user can run and schedule some repetitive jobs at a particular instance of a time. So as you have understood that what is the application that we are trying to design over here, let's start with the first step of our system designing, and that is gathering of the function requirement. So the function requirement of a job scheduler is very simple and straightforward. The main requirement is user should be able to create and schedule a particular job at any given instance of time. Maybe he want to run a job immediately, or he want to run a job in the future, or he can schedule a cron job which will run every day or every week at a particular time. So that will be our first requirement. The next one is like we have to give the user the provision to monitor the jobs. Means, for example, a job is running at a particular instance of the time, user will get a dashboard to monitor that job. Means whether the job is running successfully or not, whether it got failed, or if it had failed, what is the reason for that. So there should be a monitoring platform for the user. Number 3, user should be able to cancel or reschedule a particular job. So these are primarily all the 3 functional requirements that we have to solve in this problem. So let's first list down all the functional requirement over here. After that, we will see in our next step that what will be the non-functional requirement for this problem. So here you can see these are all the functional requirement for this problem. That is, user can create and schedule a job that can run immediately in the future, or it can be a scheduled job. Number 2, user should have the provision to monitor the status of a job, and the status should be on real time. And number 3, the application should support cancelling and updating of scheduled job at any time. So it is also possible that if a job is running at that time also, you can cancel a particular job. So these are all the main 3 functional requirements that we will be solving over here. Only one thing that will be out of scope is like we are not keeping all the jobs that are dependent on each other. So all those DAC things will be out of scope for this designing. So here we are done with the first step of our designing, and that is gathering of the functional requirement. Let's now move to the next part, and that is the gathering of the non-functional requirement. So let's list down all the non-functional requirements that are needed over here. So as you know, the first non-functional requirement that we have to deal with is the scale of the system. Means before we propose any design, we have to first understand that what will be the scale of this application that we are targeting. So here, if you ask your interviewer that what will be the scale of this application, your interviewer might tell you that the scale of this application is around 10,000. Means at a particular instance or at a peak moment, your application should support around 10,000 scheduled job at a time. So the total number of jobs that can run concurrently on your server will be around 10,000 jobs per second. So that will be our peak traffic that we are targeting. So that will be 10,000 jobs per second. Number 2, the next non-functional requirement that we discuss over here, as you know from our last video, is the cap theorem. And the cap theorem states that if you are creating a microservice or a distributed application, you have to either compromise between the availability or the consistency of a particular module. Means your module can be either highly available or it can be highly consistent. You cannot achieve both highly consistent and high availability on a particular single module. So here, if you understand the problem statement clearly, you will get to know that here we should focus on the availability of our application rather than the consistency. Let me tell you why. So for example, in your team, in the office, you have created a particular job that should run on every Friday. Now it is fine that as soon as you have created the job, it is not reflecting in the dashboard or the portal where you monitor all the list of jobs that you have created for your office. So it is fine with an eventual consistency in your application. Means as soon as you create a particular job, it is fine that you see after a delay of 1 or 2 seconds. So, and that is why here we are prioritizing the availability of the application rather than the consistency, because obviously this job scheduler should be highly available, otherwise you cannot run any job or the batch running of the job might fail. So our application should be highly available rather than consistent. So here we are considering an eventual consistent system. I think this is clear. Now the next non-functional requirement that is very much important for our application, that is a job should run at least once. Means if you have scheduled a job, it should run. So in our non-functional requirement, we have to prioritize this functionality that our job should run at least once. And the last, the most important critical non-functional requirement that we have to solve is our jobs that are scheduled in our application should get executed within 2 seconds, which means that system should execute the jobs within 2 seconds of their scheduled time. So for example, you have scheduled a job that should run at exactly 5:30. Then our application should also support that. Means our job scheduler should not pick up the job with a latency more than 2 seconds. So that is the main idea of the latency over here. So these are all the non-functional requirements that we are targeting to solve in our design. So here if you look carefully, our application should support a concurrent running of 10,000 jobs per second. Number 2, based on the CAP theorem, we are giving the priority to the availability rather than the consistency. Means our application should be eventual consistent. Number 3, all the jobs that got scheduled in our application should run at least once. And number 4, the system should execute or pick up the job from the job buffer with a maximum latency of 2 seconds. So these are all the functional and the non-functional requirements that we will be solving over here. Now, since we have understood that what are the functional and the non-functional requirements for this problem, let's go to the second step of our designing, and that is the identification of the core entity. So let's see what will be the core entities for this application. So looking at all the function and the non-functional requirement, you can easily identify that the core entities are number 1, the job that we are actually running. Number 2, the scheduler, means based on the time frame on which the job should be executed. And number 3, a executor service, which is actually the core component that will run a particular job. So these are all the core entities for our application. Now, since we are done with the 2 step of our application, that is gathering of the functional and the non-functional requirement and identification of the core entities, let's move to the next phase of our designing and the third step, and that is the API designing. So let's see what are the REST API or the public API that will be responsible to fulfill all the functional requirements that we have gathered. So as I always tell you, API designing is actually very easy if you have gathered all the functional requirements correctly, because most of the time API designing is nothing but a one-to-one mapping with one of the REST endpoint with one of the functional requirements that we have gathered. So the first REST endpoint that we have to provision over here is we have to give the functionality to the user to create and schedule a particular job. And since here we are scheduling or we are creating a job in our application, means we are submitting some data in our application, and that is why it should be a post endpoint. So the first endpoint that we will be designing over here is a post endpoint. So let's see how the signature will look like. So the first endpoint will look something like this, means it will be a post request, and here in the post body we will be actually submitting a job along with the time or the schedule when we want to run that job. So that will be the first endpoint to create or schedule a particular job. Now the next endpoint is like once the job is created in our application, the user should get the provision to see the detail of the job, means who have created the job, at what time it got created, or all the metadata that are related to a particular job. And here, as you understood, we are getting some information from our database, means we are retrieving some information. So this will be a GET call. And let's see how the signature will look like. So this is how the signature will look like. So here you can see this is our API endpoint, and here we are passing the job ID for which we want to get all the information. So here in our first API endpoint, we obviously have created a particular job, and here in the response we are getting a job ID, and that job ID we are passing over here to see all the metadata of that job. So I think that is clear. Now the next few endpoints that we need over here to fulfill all the requirements is monitor the status of the job. Number 2, provide the support to update and cancel a particular job. So here we will be having all the CRUD endpoints that is needed to manipulate and see the status of a particular job. So let me list down over here all the endpoints that is required to manipulate a job and to see the status of those jobs. After that, I will explain in detail that what each and every endpoint will do and how they will behave. So these are all the public REST endpoints that we have to provision to fulfill all the requirements that we have gathered. So let's go one by one. So the third one is we have to see the status of a particular job. Means, for example, whether the job is running or whether it got failed or not. And for that, to see the status, here we have our third endpoint, that is this one. Means here we are passing the job ID, and here we are trying to get the status of that job. And number 4, we have to give the provision to the user to update the metadata of a particular job. And that is why we are passing the job ID as a parameter. And here this is a put call to update the job metadata or the schedule time of a job. Number 4, here we are giving the provision to cancel a particular job. So for example, you want to cancel a maintenance job that will be running tomorrow. So that will be the first test case. And number 2, for example, your job is already running and in between you want to cancel that job. And for that also, we will be giving the same endpoint, that is cancelling of a particular job based on the job ID. And the last but not the least is run now. Means based on a particular job ID, you can initiate running of a job immediately. So here, if you look carefully in our function requirement, we were asked to give the provision to run a job immediately in the future or as a batch job. So here we have fulfilled all the requirements that we have gathered at the very beginning for our function requirement. So here we are done with the third step of our designing, and that is the API designing. Now let's go to the next step of our system designing, and that is the high level designing of our system, where we want to see that what are the major components that are needed to fulfill all the functional requirement of our problem. So let's move to the next part of our designing, and that is the high level designing of this application. So here, if you see, the high level designing of this application is very simple. So this is probably the most simplest designing that we will be doing among all the 8 videos that we have solved before. So let's see what can be the major module or major component that are required to fulfill our designing. So the first thing that we need is a user who will be actually scheduling the job in our application. So the first thing or the first module will be the user. So these are nothing but our clients or the user. I think this is clear. Now the next thing is like, we have to give the provision for the user to schedule a job. Means we need a job service where the user can do all these operations that we have listed over here. Means obviously, since this is a microservice application, so there should be some microservice which will be responsible to handle all this operation. And that is why we need our next component, and that is a job service. So here this will be our next service called as the job service. And here, if you see, we are creating this application for a huge amount of traffic and for a lot of users. And obviously, since here we are going with a microservice architecture rather than a monolithic architecture, so obviously we need a load balancer and an API gateway in front of this job service. So let me put a load balancer and an API gateway over here. And as you know, the responsibility of the load balancer and the API gateway is authentication and authorization, rate limiting, and number 3, routing of the traffic evenly across all our backend server. So let me list down all those functionality and the responsibility over here. Now, since we are done with some basic setup of our designing, let's see what are the additional modules that is required to design our application. So obviously, the first thing that is required is once the user want to create or schedule a particular job in our application, we have to persist that information in some database. And for that, we will be having our persistent module, means our database, which will have all the metadata of the jobs. So here we will be having our next module, that is a job DB, which will consist of all the metadata of the job. So I think this is clear. So what is happening? The user is first hitting our load balancer and our API gateway, and based on the URL endpoint, our API gateway will route the traffic to our job service, and this job service will persist that information into the database. Means whatever the user have created the job, that will get persistent in our database. So that is the first step of our designing. Now the next step is like, for example, user have scheduled a cron job that should run every day at around 5:30 am. So here we have to write some logic, or we have to design our backend application in such a way so that the job should get picked up at 5:30 and it should start with the execution. And to perform that, what we need a job executor. So here we will be having our next service that is called as a job executor, which will actually run the job. So let's see what will be the responsibility of this job executor. So the responsibility is like this job executor should scan this job database to fetch all the jobs that should run in the future. So for example, at around 5 o'clock, it should see this job database and it should pull all the jobs that should run at 5 o'clock. And if there is any job that is present that should run at 5 o'clock, it should come over here and it should just start running. So that is the responsibility of the job executor, means to pick up a particular job from our database and it should run on that instance. Clear? And once the job ran successfully, it should also update the database with the status of the job, means whether the job failed in between or it ran successfully. So also it have to push the notification to this job database, means it should update the status of the job. So here the job scheduler is actually the prime or the core component of our application, and it have two critical roles. Number one, pull all the job from this job database that need to be executed, and number two, once the job has been run successfully or it failed, it should update the status in the database. So the next responsibility will be update the status of the job. And that's it. So these are the two main core responsibility of this job executor service. So here if you look carefully, we have almost fulfilled all the functional requirement that we have gathered. That is, number one, user should have the provision to create or schedule a job, and that is done with the help of this job service. Means once the request is coming to a job service, it is getting persistent in our job database. Number two, monitor the status of the job. So whenever the user want to see what is the status of the job, another request will come to a load balancer. It will get forwarded to our job service, and from this job service we have to check what is the status of the running job in our job DB. And who is doing that? It is done by this job executor. So here, since our job executor is updating the status of the job every second or every minute, so here in the job DB also we will get the status of the current running job. So with the help of that, we can easily fulfill our second requirement, and that is monitoring the status of the job. Number three is support, update and cancel of the scheduling job, and this can also be done by this job service. So here if you see, we have fulfilled all the functional requirement that we have gathered so far. But the thing is not at all simple the way it looks like, because here if you see, there are a lot of non-functional requirements that we have to fulfill. There are a lot of small details that we have to fulfill, because in this high level designing, we have simply told that how the flow will work or how this job can be scheduled. But we have not gone in detail that how this job executor service will pick up the job from the job DB, how it will know that when the job need to be executed, whether it will pull the data every second, every minute, or what will be the action item for this job scheduler, and also how these thousands and thousands of the job will be executed by this job scheduler. So all those things we will discuss in detail in our next step of our designing, that is the low level designing or the deep dive designing of our system, where we will see in detail that how this job scheduler service will work. Because believe me, there are a lot of components that are missing over here to successfully run a particular job in our application. Because here you have to keep in mind, here we are targeting a huge amount of traffic and lot of corner cases that we have to solve over here. So without wasting much time, let's go to the next step, or probably the crucial step of our designing, that is the low level designing or the deep dive designing of our system, where we will see in detail that how a job will get scheduled, what are the parameters that are needed to schedule a job, what is the type of database that we will be using over here, how this job executor service will fetch the information from our database, and all those things we will see in detail in our next step of designing. So let's move forward to the last step of our designing, and that is the low level or the deep dive designing of our system. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So let's start with the low-level designing. So the first thing that I will do, I will copy this entire high-level designing from here and will paste it in our low-level section. Now let's start with deep dive analysis of each and every component over here, and let's see how they will interact with each other and how we can optimize this design. So if you look carefully in our designing, I have intentionally not considered this user component in our design, because in this problem statement, user flow is not at all a primary flow for this design, and that is why I have not considered designing the user flow in our application. But if you want, or if your interviewer wants that you should also design that how do we onboard a user, then feel free to add it over there. It is a very simple design to incorporate a user flow. I have already shown you in my last 8 videos. So let's now focus on the main part, and that is the job scheduler. So the first thing that we will be doing here, if you look carefully, here we are having a single service called as a job service, and the main responsibility of this service is quite huge. That is running all the operations or all the API endpoints that we have designed. Means it will not only schedule the job, it will be also show you the status of the job. It will be responsible for canceling a job, and all those responsibility we have given to a single microservice over here, which is not at all a good designing pattern. So what we will do, we will subdivide this job service into different microservices so that we can distribute the responsibility to each of them. So here what I will do, I will divide this component into 2 parts. Number 1 will be a job service and number 2 will be a search service. So let me just divide it. After that, I will discuss in detail that what will be the responsibility of each and every component. So here if you see, I have added one more component called as job search service. And here we have our previous component, that is the job service. And the responsibility of this job service is to create the job, modify the job, and to trigger any job that is required. And the responsibility of this job search service is to give the status of the job or to give the details of any job. Means all the read requests should go via this job search service, and all the other manipulation of the job, means the update, edit, delete, should go via this job service. So here we are dividing the responsibility into 2 separate services, and this service is responsible for all the edit operation and the delete operation, and this is responsible for only searching, means searching of the job based on ID, searching of the job based on the status, and all those things. So here we have first divided job service. Now here if you look carefully, since this service is responsible to create and edit a job, so what we have to do, obviously we have to provide this service the access to the database, means otherwise it cannot edit or save any data, right? And for that what we are doing, we are giving a connection for this service to the job DB. So whatever the changes that are happening in the job service will get persisted within this job DB. Clear? Now, here if you see, we are considering a huge volume of data in our application. Means there can be thousands and thousands of jobs that are triggered at a particular moment of time. And here you can see that the scale of the application is 10,000 jobs per second, and it is not mentioned properly that whether it will be a recurring job or it will be an immediate job. Means it can happen that 10,000 users are triggering their job simultaneously, or it can happen that 50% of the job are done immediately and rest 50% are the recurring job. So it is not clearly defined in the scale of the system that whether all these jobs should be triggered immediately or after some time. So here we have to scale our application in such a way that our system should be resilient enough to run all the 10,000 job immediately as soon as the user clicks on run. So to enable that feature, what we have to do, here we have to introduce some different components. So let's take an example that 10,000 users are simultaneously submitting or creating job in our application. So what will be the responsibility of this job service? It have to insert all those data in the database. And obviously this is impossible for a single server to insert all those data in a particular database. Moreover, it will be a huge load for our job database to give the provision or give the right request for each and every request that are coming from the user. So what we have to do to make this flow resilient enough, we have to introduce a Kafka broker over here. So what will happen, whatever the create request or edit requests that are coming in our job service, we will not update directly in our job database. Rather, what we'll do, we will push it in our local storage, which will be a streaming platform. So here we will introduce a Kafka broker over here. So whatever the edit request or the create request user is doing in our application, the request first go in our Kafka broker. And from this Kafka broker, we have to write a simple consumer service that will ingest all those data in our job DB. Clear? So that is a simple flow that we do normally for any application. So what we will do, here we will be having another application or another service, and the responsibility of this consumer service will be to update the job database. So whatever the job that is coming over here in different topics, that will get consumed by our consumer service, and based on that, whether it is an edit job or a new job, it will simply update the job database over here. Clear? So we are done with the first step of our designing, that is the creation or the edit of the job by the user. So this is the flow that will get triggered when you submit a job in our application or you simply do some metadata update for a particular job. Now let's see how we can optimize this search service. And as you know, there will be thousands and thousands of jobs that will get posted in our application. And with the help of this job service, what we are doing, we are trying to see two things. One is the metadata of the job based on the job ID, and number two, the status of the job that is running currently. So these are only the couple of search operations that we are performing with the help of this search service. But here if you see, we are not searching any data based on some strings or title. So it is not required to introduce an external search engine like Elasticsearch or something like that. So what we'll do, this job service will directly hit our job database to find out all the relevant information that is needed. So here all the requests that will be going through the job service will be the read request. Now since we have defined that how the job service will look like and how the search service will perform, let's now see what will be the schema structure of the job database and what type of database that we should use over here. So here if you look carefully, the information that we have to persist in a job database is nothing but a flat job information. And that is why here we will be using a Postgres solution to store all our information. So let's see what will be the tables that we will be having within this job database to store all the information. So the first table that will be present within this job DB is nothing but a job table. So let's see how the schema structure will look like. So here what we are having the job ID, the name of the job. Number 3, the schedule type, means whether it is a cron job or it is an immediate job or it will be running in the future. So here we will be mentioning the job type. Next is the status. So for example, there is a job that is running for about a month or so. Now you want to pause that job. So the status of that job will be paused. Or if you want to cancel that job, then it will be marked as cancel. So based on that, we will be giving the status accordingly. And if the job is a cron job, so it will be marked as a scheduled. So this will be the status of the job. Next is the schedule time, means for example, it is a job that you want to run on Friday at a particular time. So that timestamp will be there within this attribute. Next is the cron expression. So for example, the job that you want to run is a cron job, means it should repeat each and every day or every month or so. So it is basically a cron job, and based on that, you have have to write a cron expression. And the way to write a cron expression is very easy. It is represented by few stars and so. So here this is how the cron expression is written. The first one is the second, then comes minute, hour, day, month, and all these things. So based on that, whenever you want to run this job, you have to give the proper value over here, and based on that, the job will run successfully. So this is the industrial standard of how to represent a cron job over here. So here we are giving the option to represent a cron expression. Next is the payload. So for example, to run a particular job, you need to give some data or attribute to run that job so that you can pass within that payload field. Next comes the retries, which is a crucial thing for any job. So for example, you are running a job and for some reason your job failed. So what we have to do, we have to again reschedule the job, or we have to retry or rerun the job so that maybe in the next attempt it will pass. So there is a field called as a retry field. Based on that number of time, we will try to rerun your job if it fails for any reason. So here it is crucial to have a field called as retry. Otherwise your job will run indefinite amount of time if it could not succeed. So that is why we have to keep an option of the maximum number of retries we will permit for a particular job. So this is nothing but our job database. Now let's see what are the other tables that is needed to run a job. So here what we are considering that this job DB will have information or the metadata of all the jobs that is scheduled or about to run. Now there should be another table that will have the information of the status of the running job. So here we will be having one more table called as the job run. So let's see what will be the schema structure over here and what will be the use case it will be solving. So this is how the next table will look like. So this is the job run table, and here if you look carefully, we are having a couple of attributes. Number one is the ID, which will be an auto increment ID. Number two is a job ID, which is nothing but a foreign key for this table. Next comes the status, start time, end time, modified time, executor ID, attempt number, and the error message. Now let's see what these things actually means. So let's take an example. Here we are having a job that simply clears a data field from our database, and it runs every Friday at around 9 o'clock. So what happens is like our application or the service, this job executor will pick up that job from our database at around 9 o'clock, and then it will start with the execution. But before it starts with the execution, it will put a simple entry within this job run table so that the user can track the running status of the job. So what will happen at around 9 o'clock, an entry will come. That is, here we are having a simple ID, a auto increment ID. Then we are having the job ID that is defined over here. Next is the status, means the job has been picked and it is ready to execute. So the first status will be queued. After that, the start and the end time will be blank as of now. Then will be the modified time. So here, since we are adding an attribute in our database, so the modified time will be the present time. Then the executor ID will be null. Now what is the executor ID? I will tell you later. After that, here we are having an attempt ID. Means since it is the first attempt to run the job, so the value of this will be 1. Clear? Now once the job starts running, our executor service will again update this entry, and it will update few of the attributes. Means the job has been started running, so it will add the start time and it will change the status from queued to running. And in this way, on each and every phase of the execution, this entry will keep on changing, as well as the modified time over here. And once the job runs completely, it will be marked as success or failed. Clear? So these are mostly the two data tables that we need within our job DB. So here we are done with the few things, that is the scheduling of the job, and number 2, the searching operation, that is the search service. And here also we have defined that how the job DB looks like. So I hope till now it is clear that how we are proceeding with our design. Now let's see the main part, means how this job executor will actually work. So here what we have done in our high level designing, we have defined that this job executor will do two things. Number 1, pull the jobs that need to be executed, and after that, once the job is running, we have to update the status of the job as and when required. So these are the two functionality that we have to perform over here. But obviously, since it was a high-level designing, we have kept it like that. But in reality, this is much more complex than it actually looks like. So let's see how these things actually works. The first step this job executor service have to do is it have to pull all the job that needs to be executed. Means this executor service have to keep monitoring this job DB each and every second to see which is the job that should run in the next interval. So it is like a watcher service that will keep on scanning the whole database to see what is the next job that it need to pick. But in real life, scanning this huge database in each and every second is not a feasible solution. So let's see what can be a feasible solution and how we can optimize this design. So what we will do, I will introduce another service over here called as a watcher service. So the responsibility of pulling the job that need to be executed will get shifted to another microservice called as a watcher service. And this service will be only responsible to pick up all the jobs that needs to be run in the next moment. So let's see how it will perform. So as I told you, it is not possible to scan this entire database each and every second to see that which is the job that will run in the next second. So what we have to do, we have to reduce the number of times we are scanning this job database. So what we will do, we will run this query of fetching the job in every 20 to 30 seconds. So what this watch service will do, it will simply scan this job database and it will see that what are the jobs that need to be performed in the near future. And what should be the near future? Here we have to define a sliding window. So what this watcher service will do, it will check that what are the jobs that need to be run in the next 5 minutes, and it will pick up all those jobs from our database. So here, instead of fetching the information of each and every second, what we are doing, this watcher service is getting a bulk of data from this job DB for a time frame of 5 minutes, and it will simply store all those upcoming jobs that need to be executed in a simple queue. So what we will be doing here, we will be introducing a queue or a streaming platform. So here we will be having one more streaming platform, that is a Kafka streaming platform. And whatever the job this watcher service pulls from the DB, it will simply push it on the Kafka broker. Clear? So this watcher service is not running the job. It is simply fetching the job that need to be run in the next 5 minutes. And this watcher service is scanning this job DB every 20 seconds, for example. So this will be a read request that will go on every 20 seconds. And once it receives all those thousands and thousands of jobs that need to be executed in the next 5 minutes, it is simply storing that in a temporary variable that is nothing but a Kafka broker or a simple streaming platform. And once this watcher service pick up a particular job from the job DB, it will do one thing, that is, it will update this job run table. Means it will put an entry that the job had been picked and it is in the queued status. So here you can see this Kafka is nothing but a temporary queue, and that is why we are marking the status as queued. Means your job has been picked and it is ready to be executed, but right now it is in the ready queue. So I will just write the responsibility of the watcher service over here so that it will be clear for you to understand that what this module is actually doing. So what this watcher service is doing, it is simply pulling this job DB every 10 or 20 seconds, and it pulls all the jobs that need to be executed from now till 5 minutes. So it will pull all those information from the job DB and it will simply mark it as queued. Now what it does, it pushes the information in the Kafka broker. Now let's see how the job will actually going to perform. So what happens is, like, once the watcher service push the job in the Kafka, it will simply push it in one of the topic. Let's take an example. The name of the topic is run. So it push all the jobs in this run queue, means this job need to run next. Now once the job are there in the Kafka broker, what we have to do, we have to write a consumer service to pick up the job at the particular instance of time. So what we will do, here we will be introducing one more service as a job consumer service. So this consumer service will fetch the information from the run queue of this Kafka and it will actually start with the execution. And how it will execute? It will simply execute with the help of the executor service or the worker service. So here what we will do, I will get rid of this one and here I will be introducing worker service or the executor service over here, and after that I will explain you how the things are working. So here if you look carefully, we are having a job consumer service, and what it does, it simply look in the Kafka broker and it simply fetch the job that need to be executed right now. So it simply pick up the job from the Kafka broker and it push it to the executor service or the worker service, and this is where the execution actually happens. So till now what we are doing, we are simply fetching the job from the database and we are simply scheduling the job over here. But once the job comes in the executor service, this executor service is actually where all the operations are happening. Means for example, we need to update our database, or we have to run a Python script, or we have to run a Docker image. So whatever may be the job that need to be executed, that is done by the executor service. Now what happens is like, once the executor service is executing a particular job, it might can happen that a job will run for a 10 minutes or 15 minutes. But it is responsibility of the executor service to keep us updated that what is the running status of the job. And that is why we have to submit the status of the job in near real time, maybe in every 10 seconds. And where it will update the status? It will update the status over here, means in the job ran database. So this database will keep on getting updated every 10 seconds when the executor service is running the job. So for example, your job need to run for 10 minutes. So at the 0th minute, a request will come from the executor service that your job started running. So we will mark the start time over here and we will change the status from queue to running, and also it will change the modified time to current time. Again, after next 10 seconds, what will happen? Again, a request will be coming from the executor service that the job is still running, and we will simply update the modified time over here. Means whenever a new request or new update is coming from the executor service, we will simply update the modified time over here. And also here we will be giving the executor ID which is performing. Now the next question is how this executor service will update this job run database. So obviously it is not possible that the executor service will update this job run database each and every 10 seconds to change the status of the job. Then what we have to do? We have to go with some different approach. That is, instead of directly updating this job database directly by the executor service, what it will do? It will simply push the notification or the status within this Kafka that we have introduced. So all the status of the job, means whether it is running or not, what is the change, or everything will go within this Kafka broker. So all the new status of the job or everything will get pushed in the Kafka broker, and this information will be consumed by our consumer service, and this consumer service will update this job ran database over here. So here you can see this executor service, instead of directly updating the job database, what we are doing, it is going through a Kafka broker in a seamless fashion, so that two applications should not update a single database simultaneously. And that is why all the response from the executor service are going into the Kafka broker, and thereafter this consumer service is the only one who will be updating this job database. Clear? So I will just modify the image over here so that it will be easy for you to understand. So here you can see all the executor service is doing an update every 10 seconds, and it is posting the information in the Kafka broker. So here if you look carefully, we are almost done with the designing of the job scheduler. So here you can see what is happening once the user comes to our application. It simply submit the job with the help of the job service, and it push it in the Kafka, and our consumer service read the Kafka and submit the job in the job DB. And once the time comes for the execution, what happens is like our watches service read this job DB every 10 to 20 seconds, and it filter out all the jobs that need to be run in the next 5 minutes. And once this watcher service gets all the job, it simply push it in the Kafka. That is nothing but a queue. And this consumer service read that Kafka and execute the job with the help of the executor service over here. So here you can see we have almost covered everything that we have gathered over here. Means how to schedule the job, how to run the job, and how we should monitor the job. But if you look carefully, there are a lot of loopholes that are present till now within this application. Let me go one by one over here and let me show you that how we should perform and resolve all these issues. So for example, here we are having the executor service over here. And for some reason, while executing a bad job, this executor service fails. Then what we have to do? We have to again retrigger the job. But here in our designing, we have no provision to retrigger the job. So here we have to provision our application in such a way that the retrigger is also possible. And how we can do it? Let me tell you how. So what will happen is like, for example, while running the job itself failed within this executor service. And once the job fails, what will happen? This executor service will inform the Kafka over here that the job had failed running. So what we will do? Here we will be introducing one more topic called as a retrigger topic. Means if the job fails for the first time, it will be then pushed into our retry topic for further execution. So on our first attempt, the job was failed. Thus our executor service pushed it in this topic. Now what will happen? This job consumer service will again pull up the same job from the Kafka, but right now from the retry queue. And once the job is been picked up from the retry topic, it also have to inform the database that it is the second attempt that we are doing over here. So what it will do? Again, this job consumer service will push a notification to this Kafka that is we are having over here, and it will change the status from attempt number 1 to attempt number 2. Means on the first attempt it got failed. That is why we are doing the second attempt to run the job. So there will be an update notification that will go from here to this Kafka that we have defined over here. And thereafter this consumer service will pick up that update and it will simply update the database status. Clear? So let me just write it over here so that it will be clear for you. So here our consumer service will update the DB, means it will simply increase the retry count with the help of this consumer service and this pipeline that we have defined over here. So here we have defined the two scenarios. One is the failure scenario, that is once the job failed to run on the executor service, the executor service will update the Kafka and it will push the job in the retry queue, and once it is over here, it will again get consumed by this job consumer service and it will get further executed. And even after second to third retry, even if it failed for that last time also, what it will happen? It will get moved to the last topic, and that is the date queue. Means after that, this job cannot run. Means for example, what will happen is like within this job DB, we have predefined that a particular job should run for a maximum of 3 times. Now for the first time, once the job fails, what happens is like on the first attempt, it fails, it comes to the retry queue. So the first attempt is gone. Now in the second attempt, it will again pull from retry queue and it will mark as a second attempt. And in this way, once it reaches the threshold, that is the total number of retries, maximum retry that is possible, it will simply push it in the date queue. And once it is in the date queue, means there is no further retry should happen for that particular job, and thus this job service will update the job database using the same pipeline and it will mark the job as a failed one. Means your job failed to run successfully. I hope this is clear that how we are handling the failure scenario or how we are doing the retry. But there is one more test case, that is, for example, this executor service itself dies. So it is simply a microservice, like it is simply a server that is executing the code. So it can happen that while executing, server itself dies. Since this executor service or this server itself dies, it cannot send a notification to either the Kafka broker that it got died, or it cannot send the notification to the consumer service over here that this job got failed. Then what we will do? Because if the executor service fails to update the status, then what will happen? This job will be in the running state for an indefinite period of time, since there is no one to update the status from the running to failed. And for that, to handle that scenario, we have to do something. Now let's see how we can solve that issue. So if you look carefully, what is happening over here, this executor service is updating this job ran database each and every 10 seconds. So if you just understand this concept clearly, that this modified time that we are having in this database should get updated each and every 10 seconds. maybe we can take a buffer of 15 seconds if there is a delay for the executor service to change the status. But it is pretty clear that at the end of 10 to 15 seconds, this modified time should change. Means if this doesn't change, we can assume that there is some problem with the executor service and thus it got failed to update the status. And with this assumption only, we will solve the problem. So what we will do, here we will update our watcher service. And what this watcher service was doing, initially, it was just pulling the database every 10 to 20 seconds to pull all the jobs that need to be executed from now to 5 minutes. So that was the first step it was doing. But right now, apart from just checking only this one, there will be one more additional check that it have to do. That is, it have to also check this database to see that if there is any job that got started on time and the status of the job is running, but the modified time is more than 10 to 15 seconds, then we have to assume that that job got failed while execution. So what we have to do, we have to again retrigger the job and we have to follow the pipeline of rerunning the job. So what will happen? This watcher service will do one more thing, that is, it will pull all the data from this table where the status is running and the modified time is more than 15 seconds. So I will just write it over here so that it will be easy for you to understand. So here what the watcher services do, along with the task that was assigned previously, it is doing one more thing, that it fetches all the jobs that are in running state and the last modified timestamp is more than 15 seconds. And thus with the help of this scenario, we are diligently handling all the failed cases that might arise while running the job. So the first scenario was the job might fail due to some unknown reason, and at that time what will happen, this executor service will push the job in the retry queue, and the next is this executor service itself dies. And for that case, what is happening, based on the last modified timestamp that we are having over here, we are coming into the conclusion that the server got terminated and thus we need to retrigger the job one more time. And thus our watcher service scanning that job from this job run table and it is pushing it in the Kafka queue, and it is also increasing the number of attempt over here, because remember, the number of attempt also matters. So this is how we are handling all the failed scenario. Now if you look carefully, there is one more system requirement or one more functional requirement that we have missed. That is cancelling a scheduled job. So here if you look carefully with the application that we have designed, with this approach you can cancel a predefined job. Means for example, a job will about to execute maybe tomorrow or after a few minutes, then we can cancel that job. But there was the requirement that you want to cancel a job that is also running. Means something that is already in the executor service, we have to stop that job. And how to do that? That is not mentioned within this design. So let's see how we can achieve that. So the way we have to do it is like, once a cancel request comes to our job service, we have to do two things. One is we have to update the Kafka so that our consumer service can cancel the upcoming job that is there in the job DB. And number two, if the job is in running state, we have to stop that job. And how we can stop that? Somehow we have to find out logic by which we have to inform this executor service that we got a request from the user to stop the current running job. And for that, what we will be doing, here we need an additional service which can tell this executor service to stop the job. And what we will do, once a request is received by the job service to cancel any job, a request will go to update a cache over here. So what we are doing, we are putting the data in a simple Redis cache. So why we are doing it, I will let you know very soon. And thus, once a cancel request come for a particular job, an event got triggered over here and an entry got registered in our Redis cluster. So for example, a cancel request came for the job ID 123. Now what we have to do, to notify the executor service that a cancel request have came into the cache, we have to query this Redis cache every 10 seconds. So what is happening? While the process is running over here in the executor class, another thread will be there to talk to this Redis cache, and it will keep on checking that whether the job that is running right now, whether there is any request from the user to cancel that or not. And if the request is not there, then it will proceed with the execution. Otherwise, if there is a cancel request there in the Redis cache, then it will stop the execution of the job there only. So here all the executor service will talk to this Redis cache locally. And obviously, since this is a cache, this will be a super fast job. But remember, there is a small problem over here. That is, whatever the request that we are getting to cancel a job, we are simply pushing it over here. Maybe the job is not running at that time. So there will be a lot of dummy requests that will get generated within the Redis cluster. So to avoid that, what we will do, here we will put a TTL, means time to leave. So for example, a job is not running right now. So after 30 seconds, this entry will get deleted from here, means this is of no use. Means only the job that is running should get affected by this Redis cluster. And whatever the job that need to be cancelled for the future, that will be taken care by the consumer service over here. So we have covered more or less everything, but there are still few things that are pending. That is, we have not provisioned our system to execute a job immediately. So here if you look into our architecture, once a job gets submitted, then it goes to the job DB. And after that, this watcher service pulls that from the job DB and thereafter it gets executed. But there is no flow to directly execute the job immediately. And to implement that, we need to create another flow. That is, if the time of execution is now, means we are invoking this run now API, then what we will do, this job service will directly push that job into this Kafka broker. So here we are ignoring all these steps to schedule a job, because all these steps should get involved if it is a future job. But if the job need to be executed now, then what we are doing, we are simply pushing the job directly into the Kafka broker. Obviously, there will be one more request that will go through the consumer service to track the entry over here, but that is different thing. This is just for tracking that the job is running or not. But to execute the job and to push it into the executor service, then and then we are pushing it into the Kafka broker so that the job consumer service can pick it up from here and it can execute it now. So I hope this is clear. This is pretty straightforward and simple. I will just write the flow over here so that it will be easy for you to understand. So if the job needs to run immediately, then we are pushing it directly into the queue. So here we have completed more or less every functional requirements that we have taken into consideration at the very beginning. So here if you look carefully, we are supporting running or the execution of the job immediately. We are also supporting the job in the future. Also, we have created resilient watcher service which can pull all the jobs that should run in the future, and thus it will subsequently push it in the Kafka for further processing. So here we have covered more or less everything, but there is a small race condition that is still not covered over here. So for that, let me tell you the scenario on which this system designing will actually fail. So here if you look carefully, what we are doing by the watcher service is like, this watcher service is scanning this database in every 20 seconds. So for example, we are right now at a timestamp of 5 o'clock and this watcher service picked up all the list of jobs that need to be executed for the next 5 minutes. Clear? Now the next time this watcher service will make another call will be at 5 o'clock past 20 seconds. So this is the next time when the watcher service will make another call into the job database to see what are the other jobs that are coming in the next time frame. Clear? But here if you look carefully, there is a gap of 20 seconds. Now for example, there is a user who have created a job that should run at 5 o'clock past 10 seconds, though it is almost a job that should run immediately, but here the user is not clicking the run now button to execute the job. Rather what he is doing, he is scheduling a job that should run at this timestamp. And since right now the timestamp is 5 o'clock, so this job will not be picked by the watcher service today. Rather it will get executed tomorrow. I hope you understand. So what is happening? The watcher service is scanning the data at 5 o'clock exactly to fetch all the jobs that should get run in the next 5 minutes. Again on the 5 o'clock past 20 seconds, it will make another call to fetch all the other jobs. But in between this time frame, if there is someone who have created a job that should get executed at this time frame, then it will be a miss for today because our watcher service will never pick up right now. So to solve this race condition, we have to handle it a bit differently. I hope you got the problem statement that what can happen over here. Maybe this scenario will not happen, but it might can happen because of the way we have designed. And to solve this problem, we have to configure this job service correctly. What we have to do? So if there is any job that is getting created and that need to be executed within a time frame of 1 minute or so, means for example, I have scheduled a job right now and instead of just clicking on run now, I want that it should get automatically executed after 1 minute. So if there is any type of entry with that type of test case, what we will do, this job service will follow the same path that we have done over here. That is, it will directly send the job into the Kafka broker. Means we will bypass this watcher service. Means any job that need to be run immediately or almost immediately, it will directly push it into the Kafka broker. Clear? Now, there can be another possibility. So here we are having the watcher service that simply pulls the data every 20 seconds. But it might happen that this watcher service itself dies. And if that happens, then it will be a crucial problem. Because at that time, we do not know that till what time we have pulled the data from that job DB. And to solve that issue, what we need, here we need another Redis cluster to solve that problem. So here we will be having another Redis cluster, and here we will be saving one more attribute, and that is the last poll time, which will tell the watcher service that this is the last time frame till which you have successfully pulled all the record. So this is a Redis cache from where we will get this information. So I hope this is clear. So for example, at 5 o'clock, we have pulled all the data from our job DB, and thereafter our watcher service dies. And thus we do not have any information that till what time this job DB has been scanned. So to keep that information and to keep this watcher service stateless, we are introducing a Redis cache over here so that we can identify that till what time we have scanned this database. I hope this is clear how we are pulling data from the DB. So here if you look carefully, I have covered more or less every possible things that can be asked during the interview. But one thing I just want to point out that since this database is a Postgres database, there we need to provide some indexing and partitioning, because you can see there are a lot of read calls that are going into this database. So our database should be highly optimized to perform all those calls. So what we will do here, if you look carefully, this watcher service is the primary service that is fetching the data from the job DB. And the main attribute by which it is fetching is nothing but the schedule time. So here we have to partition this entire database based on the schedule time so that it will be easy for the watcher service to get the information from a particular partition. Next, there is one more thing, that is how to provide indexing in the job database. And here we have to put the indexing on the job ID. So here it will be indexed by the job ID and it will be partitioned by the schedule time. Because here if you see, all the APIs that we have written are trying to search based on the job ID. So this job ID should be the primary index for this table for the easy retrieval of the information. Now here for the next table, there will be a couple of index. Number one is the job ID. Next will be the status, means the status of the job, and next is the modified time over here. Let me tell you why. So here if you look carefully, this watcher service need to scan this job database based on two things. Number one, the running status of the job, and number two, the last modified timestamp. And that is why here will be a composite index, and that will be on the modified time frame and on the status field. So based on that, we can simply get all the information in a very effective manner. So here if you look carefully, we have covered everything that is required for your system designing interview. Means we have covered all the major functional and the non-functional requirement that we have gathered over here. But there can be one more follow-up question by your interviewer, and you can expect this question if you are a senior level candidate. So let me tell you what the concern of the follow-up question will arise. So here, if you look carefully, we are using a Kafka over here, and this Kafka is nothing but a queue data structure. And what we have designed is like this watcher service will pull all the data that is within the time frame of 5 minutes. That is the upcoming 5 minutes. So all those jobs that need to be run on the coming 5 minutes will come to this watcher service. Then what we will do? Obviously, since all the jobs need to be executed based on the time frame, means the schedule time, so we have to sort it and we have to push it in the Kafka. So there was no problem till now. But the problem will arrive, for example, you are pushing a job that should run immediately. So for example, all the jobs that need to be run are there already in the queue. And if there is another job that comes that should run immediately, what will happen? We are simply pushing it in the Kafka. Means we are pushing it in the queue. And once we push in the queue, what happens is like the last job that got inserted in the queue will be at the very last of the queue. So though we are pushing all this job in the queue, but it will actually execute after a given time frame when there is no other pending job before that particular job. I hope this is clear that what can be a minute test case that can fail over here, or it will not be a fail, but it will be like it will not execute immediately. So what is happening? So for example, there are hundreds job over here that are already lined up to be executed for the next 5 minutes. Now another job that need to be executed will come up and it will sit somewhere over here. So though we are assuming that we are executing the job at that moment only, but actually it is not happening. This job 101 will only execute after all the jobs get completed over here. So that is a constraint or a problem that can arise with this approach. So it is better that when you are telling that you are using a Kafka over here, you just simply tell your interviewer this can be a constraint with this approach. So your interviewer might ask you for a solution or it might not, because this is a very complex thing to solve, because with the help of the Kafka that we have chosen over here, this cannot be solved. This can only be solved if we are using some different technology or service to perform this. So I will just list down what can be an alternative to this Kafka broker to solve this problem. So let me list down all those things over here. So to solve that problem, the first alternative is to use a Redis Sorted Set. So what it is like? It is simply like a Redis cache, but here while we are adding any job, this Redis cache will automatically sort the new entry based on the time frame. And based on that, this consumer service can pick up the job from there. And thus, it will solve the problem that whenever a job that is 101 comes at the very end, though it comes at the very late, but this Redis sorted set will sort the entire bucket with the help of the timestamp, and thus it can easily execute the job on the time you want. So that can be one of the alternative approach or one of the alternative of the Kafka, and there can be another solution, and that is the Amazon SQS. So this is only applicable if you are using Amazon services, means you are hosting your entire application in Amazon, but probably your interviewer will not like this Amazon SQS solution, because with the help of this solution, all this problem will be gone. You do not have to worry about sorting or anything that you need to design for yourself. It will be just a plug and play solution for you. Means with the help of the Amazon SQS is simply support scheduling at any particular time you want. So this will be the two alternative approaches for this Kafka broker that we have introduced over here. I hope this is clear, and I have also cleared the follow-up question that you might encounter if you are getting this question during your interview. And one more follow-up question your interviewer might ask you, that is, what if your job fails? Then how the user will know the reason, or how he will get the access to the log? So for that, here what we have to do, here we have to implement a logging service for all the executor service that is running on. So all the logs will be deposited in some logging environment, and based on that you can simply update the database, that is the error message. So here in case of the error message, you can simply give URL of that job log. I hope this is clear that what can be the possible follow-up question for this problem. So I hope you have thoroughly understand that video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you in our next video where we will be solving another problem on system designing. See you on our next video. Thank you.